Hello, Math 141. We do have an inequality that we're going to be solving. My first step is going to be to try to factor the numerator. I have four parts, so I'm going to use factor by grouping. Here's one group, and here is the other group. So from the first group, I can factor out x to the second. That will result in x plus 3. From the second part, I can factor out a minus 9. So I have x plus 3 all over x plus 4 smaller than or equal to 0. Now notice that of these two groups, I have x plus 3 in common. So I'm going to go ahead and factor that over x plus 4 smaller than or equal to 0. And notice that here x squared minus 9 is factorable. So I'm going to factor x plus 3, x plus 3, x minus 3 over x plus 4 smaller than or equal to 0. And now notice I have two factors of x plus 3. So let me go to the next page and rewrite this as x plus 3 quantity squared, x minus 3 over x plus 4 smaller than or equal to 0. Let me plug in my number line. Or if you prefer x-axis. If I set the numerator equal to 0, so x plus 3 equals 0 gives me x equals negative 3. So here's a critical point, negative 3. And x minus 3 equals 0 gives me x equals positive 3. And finally, I know that when x is negative 4, then we have a vertical asymptote. So I have a point of interest at negative 4. Negative 4 is not in the domain of this rational function. All right. So let's test numbers. To the left of negative 4, if I, let's say, let's test negative 5. Okay. So if I put negative 5 plus 3 squared, negative 5 minus 3 over negative 5 plus 4, that this part gives me, since this is to the second power, gives me positive, negative over negative. End result is going to be positive, and a positive number cannot be smaller than 0 or equal to 0. So I'm going to put false to the left of negative 4. I also know that negative 4 itself is not, in the domain, because negative 4 would make this inequality undefined. So let's test a number between negative 3 and negative 4. And let's say negative 3.5. Let's test negative 3.5. So I have negative 3.5 plus 3 and negative 3.5 minus 3 over negative 3.5 plus 4. So I get a positive, I get a negative, I get a positive. End result is going to be negative, and a negative number is part of the, is smaller than or equal to 0. So I'm going to put true in here. So the next number that I'm going to test is negative 3 itself. Negative 3 itself. So if I put negative 3 plus 3 over negative 3 times negative 3 minus 3, negative 3 plus 4. So here I get a 0. 0 squared is 0 times positive 9 is 0 over 1. That is 0. And 0 is in the domain of this inequality. So I'm going to go ahead and put true. The next number has to be between -3 and +3. So let's test 0. If I test 0, so I get 0 plus 3, 0 minus 3, 0 plus 4. So I would get positive, a negative, a positive. The end result is going to be negative. Yes, it is a negative number is smaller than or equal to 0. So true. The next number that I'm going to be testing is positive 3. If I plug in, so test 3. So I get 3 plus 3, 3 minus 3, and 3 plus 4. And let me, so I would get this right here. This right here is going to give me positive 27, positive times 0 over positive. So it's 0 divided by positive. So that the end result is 0. And 0 is part of the domain. 0 does, when the left-hand side is 0, this inequality is true. So I'm going to put T in here. And finally, one number that we can test would be to the right of 3. And let's try, let's say 4. Let's try 4, test 4. Well, I get 4 plus 3, 4 minus 3, 4 plus 4. And this is going to give me positive. This is going to give me positive. And this is going to give me positive. The end result is positive. And a positive number cannot be smaller than or equal to 0. So I'm going to put false in here. So what is my solution set? Using interval notation, starting from -4, but -4 is not included, and go through all the way to 3, positive 3, and positive 3 is included. So that's the only interval between -4 and 3 that makes this inequality true. In other words, if you graph this inequality, you will see that from -4, from x's, from -4, but -4 not included, all the way to 3, 3 included, the graph is below x-axis and touching, and at 3, it's touching the x-axis. Okay, let's do one more. Let's say that if I have, I'll try to do this one a little bit faster. X minus 3 over 2x plus 5 greater than or equal to 1. First thing I'm going to do, I'm going to say that this is the same as x minus 3 over 2x plus 5 minus 1 greater than or equal to 0. Using least common denominator, now I have x plus 3, 2x plus 5 minus 2x plus 5 over 2x plus 5, which is a 1 greater than or equal to 0. So now I have 2x plus 3 minus 2x minus 5 all over 2x plus 5 greater than or equal to 0. And okay, so Oh, wait a minute. This was x. It wasn't 2x. So combining the like terms, uh, x and minus 2x gives me minus x, and negative 5 and 3 gives me minus 2 all over 2x plus 5 greater than or equal to 0. Let me go to the next page, please. So minus x minus 8 over 2x plus 5 greater than or equal to 0. What are the points that I can, if I set the numerator equals 0, so minus x minus 8 equals 0, minus x 8 minus x equals positive 8, x equals negative 8. So that's a critical point right there. And if I set 2x plus 5 equals 0, I get x equals minus 5 half. And I know at x equals negative 5 half, I do have 0 in the denominator. This rational function will be undefined. So negative 5 half is not part of the domain of this rational function. So that makes it a point of interest. So let's see. Let's say if negative 8 is in here and negative 5 half is in here, if I plug in a number to the left of negative 8 into my rational function, I get a false statement. How about negative 8 itself? Negative 8 itself gives me a 0 on the numerator. Yes, so that's true for negative 8. A number between negative 8 and negative 5 half. Let's say negative 3. That'll give me a negative. Yes, it'll give me a true statement. Negative 5 half itself is not in the domain, so I'm going to put a little f for false. And to the right of negative 5 half, let's say 0. If I plug in 0, I get a negative number on the left-hand side. And so a negative number is not greater than or equal to 0, so false. So my final answer is going to be starting from negative 8 all the way to negative 5 half. And negative 5 half is not included. And this is how we use uh, interval notation. I hope you find these examples helpful. Thank you.